All right. When we talk about chapter 2, right, for Form 4 Physics, forces and motion, the first idea we have to know what is linear motion, movement of objects in a straight line. Linear motion refers to movement of object in a straight line. And then there is a lot of formulas related to the movement of object in a straight line, such as the speed formula, the velocity formula, the acceleration formula, the deceleration formula, the average speed, the average velocity. Okay, so these are the formulas we'll discuss today. Okay, beside all these formulas, all right, okay, you also have to know the differences between distance and displacement. Okay, what are the differences between distance and displacement? So we look at it here. We learned all this in the previous classes earlier. Distance refers to how far an object travels during motion. So the object have traveled from A to B, the whole distance, okay, how far the object traveled. And distance is always a scalar quantity, so it's not going to refer to any direction. Displacement is how far is an object from a reference point. Object started at one point, after movement, where is it stopping? From the point it stopped, you draw a straight line to the point where it started. So displacement refers to how far is an object from the reference point. Okay. So today we're going to look at all the formulas again. These are the formulas we learned earlier. Okay, if you talk about speed, we know the formula of speed. Speed was actually distance per time. So speed is actually rate of change of distance per time. All right, the unit for SI unit will be still meter per second. So it should be again meter per second is the SI unit. All right, the formula is simple. Speed is distance per time. Velocity is the rate of change of displacement. So velocity is displacement per time. All right. So the unit is still meter per second. The difference, velocity is a vector quantity, speed is a scalar quantity. So velocity can have positive and negative units, values, sorry, not units, okay? So you can refer a velocity from left to right as positive 10 meter per second. So if the person moved back, the body, the object moved back from right to left, then the velocity will become negative 10 meter per second, because velocity is a vector quantity. So when you refer one direction as positive, the opposite direction must be negative. So speed, velocity. Then we have acceleration. Acceleration is the rate of change of velocity, the rate of changes of velocity. So acceleration always refers to final velocity minus initial velocity over the time it took to the changes. All right. So the formula is simple. A equals to V minus U per T. All right. The SI units here, velocity here will be meter per second. Time also second. So we will get meter per second square. This is acceleration, meter per second square. That's so speed done, velocity done, acceleration done. In a common way, we'll tell acceleration is an increase in velocity, right? It's vector quantity. Deceleration normally refers to a decrease in velocity, but it's still the rate of changes of velocity. So deceleration also will have the same formula as final velocity minus initial velocity over the period of time. All right. So the formula remain the same. A equals to V minus U per T. V refers to final velocity. U refers to initial velocity over time. And the unit also remain the same, meter per second square. This is the SI unit for deceleration, same, all right? So deceleration normally will have a decrease in velocity. So you might get A is equals to a negative value, all right? So speed, velocity, acceleration, deceleration. The formulas that you need to know for this 2.1 of Force and Motion Part 1, Chapter 2, Form 4 are the basic formulas of linear motions. V equals to U plus AT. Actually, this formula came from the first formula just now. The first formula just now was A equals to V minus U per T, right? So when you rewrite AT is equals to V minus U. So when you rewrite again, you get V equals to U plus AT. You bring the negative the other side, you get V equals to, all right, you get V equals to AT plus U, or V equals to U plus AT. So there are four common formulas for linear motion. First formula, second formula, third one, fourth one, and the average speed and average velocity. You need to know the formulas, all right? Of course, in the exam, certain formulas will be given, but you need to know the formulas, how to use. Let's look at the differences in the formulas. If you see, notice carefully, all right, what are the differences in the formula? In the first formula here, in the first formula, if you notice carefully, in the first formula, S is not given. See, S is not given. In the second formula, A is not given. In the third formula, V is not there. And the last formula, T is not there. So every formula will have four unknowns. Four unknowns. You see the first formula, it consists of final velocity, acceleration, time, and initial velocity. So this formula do not have the distance or displacement is not there. Look at the second formula, consists of T, time, final velocity, initial velocity, and displacement. A, acceleration, is not there. So this is how we look at the formulas. We realize that certain formulas, most of the formulas will have four unknowns, three will be given, three information will be given. You look for the fourth one. This is how we solve and we use the formulas, all right? So A and B, you look at the formulas, all right? Okay. Formula A is the common one. This is the acceleration equals to final velocity minus initial velocity per time. The same formula. All right. So these are the common formulas. So if you look at it, this is the last two. Earlier you saw the first two formulas. This is the last two. Of course, you have to include the average speed and average velocity formulas. So if you see this formula is the third formula in linear motion, S equals to ut plus half at square. So distance or displacement is there, acceleration, time, and initial velocity. So final velocity is not found in this formula. For the last formula, you see displacement or distance given, acceleration given, final velocity, initial velocity given, time is not given. So you use a formula based on the information given. So I will tell it's like a code. You read a question, If the question consists of A, consists of T, consists of U, and they're looking for S. So you must use Satu, this formula, because the formula gave you four infos, three unknowns are given, acceleration, time, and initial velocity is given. You're only looking for displacement. So the relationship is Satu. So this is the information given. So you have to use this formula. This is how we play with the formula. Same goes to this question. See here. You read the question thoroughly, and then you see what is the information given. Okay, A given, S given, U given, V is missing. So you use this formula. I call it SAU. Okay, use this formula because these are the information given, and you are looking for the final velocity. So it's like reading a question, breaking a code, identifying what are the unknowns given, use that unknown to solve the problem. All right. So this is how we use the formulas. Okay. By using all the formulas you learned just now, let's try to solve this. Okay. A car travels 20 minutes and is brought to rest by applications of its brakes. All right. The distance traveled before stopping is 8 kilometers. Calculate average velocity. So average velocity will be total distance or total displacement because velocity, which is given as 8 kilometers. Change the 8 kilometers to 8,000 meter. I'm trying to give the final answer in SI units. And the average velocity formula is total displacement per total time. Total time is 20 minutes. Change it to seconds. Seconds. So you should get your answer. What is the answer, guys? Guys, tekan what's your answer? 8,000 divided by 1200. What we get, guys? 6.67 meter per second. Ini cara tulis meter per second. 6.67 meter per second. Alright. Yes. Okay. For number 2, read the question thoroughly. A car begin to move from rest. Any movement from rest, initial velocity should be 0. And accelerates, acceleration given 14 meter per second square. The time taken for 60 seconds. So calculate the distance travel. This is the distance travel. Calculate. So as I said earlier, in this question, you have initial velocity from rest 0. Acceleration 14. The time taken 60 seconds. You are looking for the distance travel. So it's satu. If you see satu, your formula will be S equals to UT plus half AT squared. So I said you have to half-file your formula first, then you will know based on this information which formula to be used. So S equals to U was 0, time was 60, plus half, A is given 14, and the time taken is 60. So what is the value we get? What is the value of S? Okay, can you all solve for me each part, guys? When you solve this, you get the answer 25,200 meter. That's the answer. Okay. So technique of solving, first identify the informations given. Based on that particular informations, choose the right formula to be used. Then substitute the values, then solve the problem. Then you get your answer. Okay, let's move on to number 3. A jet moving with a constant velocity, of 1,000 meter per second, right? 1,000 meter per second increases the rate of combustion in the combustion chamber to increase its velocity to 2,000 meter per second in 40 seconds. What is the acceleration? So initial velocity found to be 1,000 meter per second. Increases the rate of combustion in the combustion chamber to increase the velocity 2,000. So final velocity is 2,000 meter per second. And the time it took was in 40 seconds. 40 seconds. What is the acceleration? So it's a direct formula question. VATU. If you get Vatu VATU, it's a direct formula. You just need to use the direct formula. The direct formula is A is equals to V minus U per T. So what was what was V? V is 2,000. You see the question carefully. 2,000 meter per second. Initial velocity was 1,000. 1,000 meter per second. And the time taken is a perfect 40 seconds. 40 seconds. So what we get? So what we get, guys? The answer for this question is 25 meter per second square because this is acceleration. Acceleration, the SI unit must be meter per second square. All right, done for. Okay, see here, it's a direct question. A car begins to move from rest. So anything moving from rest, initial velocity 0, accelerate with an acceleration given 12 meter per second square for 40 seconds. 40 seconds. Calculate the distance traveled. So again, it's a satu. When it's a satu, S equals to UT plus half AT square. So remember, the formula works with the you read the question, you identify the infos from the question, then relate these four unknowns to this formula. So distance travel, initial velocity 0, time taken 40 seconds plus half, acceleration 12, and the time taken is 40 power 2. Okay, what's the answer? Guys, what's the answer, guys? So the answer for this question is 9,600 meter. You see 0 times 40, 0, so not included. 12 divided by 2 is 6, 40 power 2 is 1,600. Okay, done with this question. Thank you, guys. Okay, a rocket moving with a constant velocity of 800 meter per second increases its velocity to 1,600 in 10 seconds. What is the acceleration? So initial velocity was 800, all right, and the final velocity is 1,600, and all this happened in 10 seconds. So we are looking for the acceleration. So it's a direct Vatu. Vatu means the formula was what? A equals to V minus U per T. So you just use a direct formula. A equals to V minus U per T. So V here is 1,600 meter per second. Initial velocity 800 meter per second. And the time taken for these changes is 10 seconds. So we should get an answer of if you have problem in solving this, please talk to me. Okay, I can explain to you how to solve this. 1,600 minus 800 is 800. 800 divided by 10, you get 80. All right. You must know how to solve this. All right. Any object dropped from a certain height, initial velocity is 0. It is falling to a certain height. The height is the distance it is falling. You are looking for final velocity, and the gravitational acceleration was not given. It's actually A. Because any object falling towards Earth must have gravitational acceleration. So let's say I give it as 9.81. Sometimes they'll give it as 10. Okay, today we are using 9.81 because your syllabus remember using 9.81. So now the formula is SAVU. If you're using SAVU, the accurate formula to be used is, I call it a SAVU, right? V square equals to U square plus 2AS. The actual formula to be used is V square equals to U square plus 2AS. What is V? We are looking for V, final velocity. Initial velocity was 0, so take away this one, gone. 2. A was given 9.81 and S is given 4 meter, 4. So V should be a square root of what? Should be 78.48. All right. So V should be berapa guys? 8.86 meter per second. So always remember the hidden information whenever objects are thrown, we release or throw anything downward. The hidden information is this. You must understand any object you throw from a certain height, the gravitational acceleration is not given because they want you to know the value. And anything you release and drop from a certain height, initial velocity is 0, right? So you know there's information of u as va. The formula sticks to v square equals to u square plus 2as. This is how we solve this, right? Okay. Okay, number 7, it's a question where you need to understand how to change a unit from another unit. So number 7 is a bit tricky question. Okay, see here carefully. How to solve number 7. Okay, see here. A train was traveling at a constant velocity of 100 kilometer per hour. All right, so it was traveling at initial velocity of 100 kilometer per hour, and it was stopped in 40 seconds. It took 40 seconds to be stopped. So once an object moving and you stop the object, so the final velocity should be 0. Okay. What is the distance traveled? Distance traveled. So the trickiest part here is to change this kilometer per hour to meter per second. So all of you listen to me carefully. Okay. We were given 100. We were given 100, right, kilometer per hour. There are two ways. You can solve with your calculator, a direct way of doing, or you can use a simple mechanism. Okay. If you are changing anything from kilometer per hour to meter per second, you just times the value given. Sorry, 100, right? I wrote it wrongly already. You just times the value given, 100, 100. You're changing kilometer per hour to meter per second. You just times whatever is given with 10 over 36. So anytime you're changing kilometer per hour to meter per second, just times 10 over 36, you will get your answer. So this answer will be 27.78 meter per second. So 100 kilometer per hour to meter per second is just 27% kilometer, 27% meter per second. You might be asking why. It's very easy. See, 100 kilometer per hour was actually equivalent to 100 kilometer per 1 hour. If I'm changing the whole unit kilometer to meter, I have to take 100 times. Kilometer to meter is 1000 meter times 1000. 1 hour changed to second is 3600 seconds. So if you see carefully here, right, potong, potong, take away these two zeros. So you will end up getting, it's actually 100, the value given was 100, so 100, all right, times 10 over 36. Your answer is in now meter per second. Your answer is in meter per second. So this is how we solve this part. We solve this part, okay? So we solve this part. So we go back to that question just now. Okay, so I redo again for y'all. So a train was traveling at initial velocity of 100 kilometer per hour. You want to change it to meter per second. I say just times 10 over 36. Your answer will be meter per second. So you end up getting 27.78 meter per second. This was the initial velocity. It was stopped. So the final velocity is 0. And it took 40 seconds. 40 seconds. What was the distance traveled? So it is actually TVUS. When you say TVUS, Your formula will be S equals to half U plus V times T. The formulas are given earlier, so you have to adapt yourself to understand if this is the information given, this is the formula to be used. If TVUS is given, TVUS is given, this is the formula to be used. So let's solve the problem. Initial was 27.78 meter per second. Final is 0. And the time taken is 40 seconds. So what is the distance traveled? Let's calculate. So the answer here, when you solve this, you get 555.6 meter. First, I divide the 40 by 2, I get 20. 20 times 27.78, I get 555.6 meter. Okay, any question, anyone? A boy runs from left end of the school field to the right end of the school field. The distance of the field from left end to the right is 400. What will be the boy's velocity? Velocity, right? If he runs from the left end to the right end. So it is 400 meter. Now it is displacement because velocity, you're looking for velocity over 60 seconds. So we end up getting 400 divided by 60. All right. So we're getting 400 divided by 60. We get 6.67 meter per second. Okay. Now look at number 2. The boy runs from right end to the left. So now when you took the left to the right as positive 400 meter, now you have to take it as negative 400 meter because velocity is the rate of changes of displacement. So negative 400 meter over 80 seconds. So you getting an answer of negative 5 meter per second. So the idea here, when you choose the displacement to the right as positive 400 meter, the displacement to the left you have to choose as negative 400 meter because velocity refer to displacement over time. Velocity refer to displacement over time. If one direction you took as positive displacement, the opposite direction must be negative. That's why you get different answers here. One was positive, the other one is negative, right? Okay, let's solve number 9 now. Let's solve number 9 now. Any question, anyone? Okay, how to solve number 9? Let's look at number 9 now. Okay. So we are playing with all the formulas that we know today. We are playing with the formula A equals to V minus U per T. S equals to half U plus V times T. All right. Then we have the formula of V square equals to U square plus 2AS. Then what are the formulas we have? S equals to UT plus half AT square. So these are the formulas we have now. A bullet leaves the gun of length. The length is the distance or displacement. A distance of 80 centimeter. And the next one, at the speed of 100 meter per second, it's leaving the gun of length 80 cm at the speed of 100 meter per second. That means the final velocity when leaving the gun is 100 meter per second. Initially, before you pull your trigger, the bullet was at rest. So initial velocity was 0. All right. Find the time taken for the bullet to travel in the gun. What was the time? So if you see here, I have information of the distance or the length. Final velocity leaving the gun is 100 meter per second. Initial velocity must be 0 because the bullet should have been at rest initially and we are looking for time. you look at it, it's TVUS. This is the formula that represent TVUS. If you know, this is the formula. So I will use this formula based on the code we have. This is the formula to be used. Okay, so S equals to half U plus V times T. So S is 80 centimeter, which we take as 0.8 meter. All right, I bring the 2 up here, so times 2. Initial velocity is 0, so no need to be bothered. Don't bother about that. Leaving the gun, final velocity when leaving the gun was 100 meter per second. You are looking for the time. So you will get here 0.8 times 2 is 1.6 equals to 100 times time. So the time here will be 0.012 1/6 seconds. Correct, right? 1/6 divided by 100. 1.6, sorry, 1.6 divided by 100. So we get, yes, 0.01 seconds. That's the answer. All right. So I repeat again. Read the question. Step 1, read the question. Step 2, identify what is the information you get. Step 3, use the correct formula related to the information you have. This is how we solve all the formulas related to linear motion. These are the 4 formulas that you have to look into. Make sure you master these 4 formulas. First one, second one, third one, and the last one. We got another 2 more formulas: average speed, total distance per total time, and average velocity, total displacement per total time. So these are the 6 formulas you have to master to complete 2.1. To complete 2.1.